Hello everyone, welcome to my channel. Welcome to another video on GPR. This is the first time I'm doing this FaceTime, and in this video I'm basically going to discuss or walk you through how you can set up a 200 megahertz GPR antenna along with an 80 megahertz GPR antenna. So the steps I'll be covering, that is more of a general steps, but the example I'll be taking, that is from GSSI SIR 3000 system, if you are familiar. And one thing I like to mention, that this video is going to be in English. So some of you were asking that I don't understand Hindi, so please make a video in English. So if you are fluent in Hindi, I have already covered this in my previous videos, so you can go and check those out. The links will be in the descriptions. So the content will be presented in English. And also I'm very sorry, I'm extremely sorry that my editing skills are not that up to the mark, and I basically keep it very simple editing. I generally don't have much time to do this YouTube thing. It's kind of my hobby nowadays. And but I'm promising you that the informations I'll be providing, that will be straightforward, and the videos will be straightforward and informative video. So let's get started. So at the very beginning, I'll be discussing about how we can navigate through the control panel and how you will set up a 200 megahertz GPR antenna. And for this part, I'm assuming that you are familiar with the SIR 3000 system, and you are also familiar with the GPR components. Okay, what are the GPR components? Like this control unit, you are familiar with 200 megahertz antenna, and you can connect the control cable and the calibration wheel with the control unit. I'm assuming that. So this is the control unit SIR 3000. There are several buttons. You can see here, it's marked here. And this, among which this is very important, this is called the function key. This is the power button. I'm assuming this part you already know. Okay, so if I move to the next part, that when you on it, when you on the control panel with by pressing this button, you will be seeing several mode or several options, like the terra search mode, like the concrete scan mode, like the structure scan mode, and each of the modes are associated with one of the function keys. Okay, that will be your initial monitor or initial display. So what is a control unit? Control unit basically you can say it's a computer, or you can say it's a portable computer. It's a basically CPU plus display, or you can say it's a laptop. Okay, whatever. So it's a compact system where you can transmit and store your GPR signals. Okay, and this basically this is a compact system, and it basically used Windows 7. GSSI basically used Windows 7. Some other, if you are purchasing from other companies or a other manufacturer, they will provide you a laptop, simple laptop, where your acquisition software will be installed. So basically this is a laptop. So, and in this mode or in this point, you'll be having several modes where you can, any mode you can choose, okay, depending on your aim. But I'll suggest you will be choosing this Terra search mode, okay. And now I'll describe, because this concrete scan, structure scan, utility scan, these are predefined modes. What is predefined modes? Means they've already set up some set up the parameters. You don't have to do anything. You just go select your scan, and you start scanning. But in the Terra search system or Terra search option, you will be setting up your entire parameters. And I think for the geological investigation or for any other survey, Terra search mode is good. So you will be going for or opting for the Terra search mode. So now you press this button, this one, you press this button and you move forward, you will be seeing like this. Okay, so there is a command bar at the below. You will be having main data display window, and you will be having four menus. What are the four menus? One is called collect, which is very important for data acquisition system. For data acquisition, this mode is very much important. Second would be the playback. Okay. Third would be I'll be discussing each and every point in details in this video. Okay. Third would be the output, and fourth would be the system. What are these? I will discuss in details. Okay, don't worry. So first, what you are seeing here, that there is a command bar, there are some parameter selection menus, and you are seeing one oscilloscope. This is called oscilloscope, oscope. Cursor. If you put this cursor on some point, okay, or some line you are marking, and that oscilloscope part will be shown in the right hand side. I'm assuming this part until this part is clear. Okay. Now, after doing that, you will be going to the main or the important part I've already told you, that is called the collect mode. Okay. For the data acquisition system, collect mode is very important. So this is you can see a plus sign here. So when you click the collect mode by pressing OK, there is a OK button there. And in the collect mode, you will be seeing several several sub menus, like radar menu is there, scan menu is there, gain is there, position is there, filters is there, and each and every point here is very important. So please watch the whole video if you are a beginner, or if you just started your work in GPR, it will be helpful for you. I will discuss what range you have to select and why you have to select that range. Okay. So let's jump into the collect menu, and I'll be discussing each and every point in details. First menu you will be encountering, that is radar. Okay. And under this radar menu, you will be having several sub menus. So first menu you can see that's written in megahertz. That will be your antenna type. Okay. So at first you have to select the antenna type. It could be of 400 megahertz. Okay. It could be of, let's say, 270 megahertz. There are several drop down menus you can see like this. Okay. If you select this point, and you will be seeing several drop down menus where you will be seeing 400 megahertz, 270 megahertz, 200 megahertz, or custom. Okay. As I'm discussing about the 200 megahertz monostatic antenna, I'll be using 200 megahertz in this place. So what happened to your antenna type? It becomes 200 megahertz antenna. Second, so second point you are seeing here, that is called the transmit rate. Okay, transmit rate or T rate, and this is defined by the manufacturer. T rate basically is the transmit rate in kilohertz. In GSSI SIR 3000 system, the maximum transmit rate you can get is 100 kilohertz. Then what's the significance of this T rate? Okay, so this transmit rate, if transmit rate is faster, this is very much important. I'm coming to that point. If you want to take faster data, then you will be putting, or then you will be giving higher transmit rate, like you will be giving 1 kilohertz. But not everywhere every antenna is equipped or compatible with 1 kilohertz transmit rate. Which antennas are capable enough? Antennas frequency greater than 200 megahertz, okay, to the gigahertz level, they can transmit, okay, they can transmit in 100 kilohertz. Okay, that's the maximum one. Now what will happen if you choose a higher transmit rate? If you by some mean you have chosen higher transmit rate, then what will be happening? The system will be beeping, and when it's beeping, you have to take care, you have to look through why it's beeping. There are several reasons the control unit might be, okay. And if it's beeping continuously, due to this you have taken a higher transmit rate, then it may damage your system. It could damage your system. So you have to check it or recheck it, check it twice to understand what T rate you have to select. Okay. Now for the third point here, that is mode. Mode could be of three types. One could be of point mode. Second is your distance mode, which is also in layman terms or originality, it is also the continuous scanning mode. Okay. And third would be the time mode. So point mode is used when the terrain is very difficult. Terrain is not so good. Okay. In that condition, you will be using point mode. And point mode is time taking. It's not fast. Okay. It's a very slow data acquisition process. What about the distance mode? This is most recommended. This is most recommended. Okay. And this distance mode, what you will be doing, you will be scanning the surface. Okay. Distance mode, then you can walk and just drag the GPR antenna. It will scan the surface, subsurface. Okay. Third is the time mode. This is there are some specific cases you will be using this time mode. Suppose you are using a vehicle. Sometimes you don't have much time and you are using vehicle. In that condition, you will be using a time mode, and for that you have to do a different setting. I'll come to that. I'll discuss about that. You have to consider different kind of setting, like time per scan per second. You have to choose very carefully. Okay, so this is not so much convenient. Okay, sometimes I did that, but I don't find this convenient. I'll suggest you to go for the distance mode. Okay, so what mode you will be selecting? The mode you will be selecting, that is the distance mode. As for beginner or for inexperienced user, this will be your distance mode. Now GPS. So generally GSSI SIR 3000 system comes with a GPS compatibility, and that's GPS name G30L. If I'm not wrong, yes, it's G30L. And if you attach that G30L GPS, then it will show to your system that GPS is active, and you will be selecting G30L. Okay. If you are using different GPS antenna attached to that GSSI system, I don't recommend that. And then you have to select custom. Okay. Then you have to select custom. Okay. And if you don't have any GPS system, because other than the GPR system, if you purchase GPS, it will be costly, and this might cost you a large chunk of money. So if you are not using that GPS, you can use a handheld German GPS. It will cost you around 10,000 INR. Okay. uh, this is handheld GPS. Okay. And you can, I have already discussed in some of my videos that how you will be using that GPS. So I'll suggest you go and check the video, those videos out. Okay. Next important point is scan. Now I'll be discussing under the what are the parameters you have to set under scan menu. First, you have to go through the samples. So this is samples. Samples means is basically samples per scan. Okay. So the samples per scan, GSSI, first let me tell you, GSSI recommends 512 or 1024. I recommend go for 1024. If you are using 200 megahertz antenna, why you don't go for 1024? Okay. Okay. So what samples per scan mean? Each curve each curve is made up of several data points. So it's made up of several data points. Okay, these curves are made up of several data points, and by specifying this means you are specifying that this number of samples should be per scan. Per scan curve, it contains 1024, it contains 512 data points. Okay, higher the number is, if the number is obviously, if the number is higher, then your resolution will be higher. Okay, am I clear? So if you are taking 1024, you will get higher resolution data comparing to the 512. um, uh, More the sample you collect, the vertical resolution or the resolution will be higher. Okay. Next is, so the next point you have to consider, that is the format. GPR is a digital system. It records the digital data. So this data can be collected either in 8-bit system or 8-bit format or in 16-bit format. So 16-bit is recommended because it will give you great dynamic range. It will give you great dynamic range. Meaning, so what's the meaning of that? That there is more information in the data if you are using 16-bit data. Okay, and don't worry about the storage. Do not worry about the storage. There will be enough storage in the GPR system, and I'll suggest you to buy one flash card. Okay, one flash card of 2 GB. I think 2 GB is supported. So instead of using the storage, then you connecting some parent pen drive, use your flash card and remove the flash card. I'll describe how why you should use the flash card and how you can remove the flash card and transfer the data from your flash card to your computer. So I'll suggest you will buy one flash card and don't worry about the storage. If you survey for entire day, it will not be full. 100-meter GPR data generally around 100 KB. So you can get the idea. Okay, and if you survey a total day, if you survey the whole day, it won't be filled up. So I think you should go for the 16-bit format. So what samples you are taking? Samples you are taking 1024 samples per scan, and the format you will be choosing, that is 16-bit. Okay, now you have to select the range. What is range? If you have to select the range means the time window you will be selecting to record the data. So I have a theory, or I have a general, I do this in the field, that I take larger time window, that so that I can see the maximum depth of signal penetration. So this, there will be a high amplitude straight line like this. You can understand that will be kind of like a white noise. Below of that you will be seeing the white noise. So this will be the depth of maximum signal penetration, and I would like to see this thing on my radiogram. Okay, so I'll be taking a larger time window. So in 200 megahertz antenna, generally the GSSI suggests that you take 150 nanosecond. That's recommended by GSSI. I generally go for 200 nanosecond. The reason I have described already, that I want to see the maximum depth of signal penetration. Okay. Next after range is dielectric. DIEL means dielectric. So this is the dielectric. Okay. And dielectric, you can choose anything. And again, like let's say you have chosen 10 or you have chosen 11. It doesn't matter. Until unless you know the dielectric. I highly doubt that you know the dielectric of the subsurface. If you know that what's the dielectric of the subsurface, then you put that value. Okay. And most of the cases you won't know, you will not be having any idea what will be the dialer. So you put 10. So why this value is required? This is used to generally GPR signal store the data in two-way travel time, TWT. Okay, and that's in nanosecond. Okay, but and if you want to see that section in depth, then they required the dielectric constant. Okay, so V equals to root over C by epsilon R, where epsilon r is the dielectric constant. From V, you will be multiplying with the T, and you will be getting half of TWT. Okay, so because it's a 2L travel time, you will get the depth. So for depth calculation, this value you need to put. Otherwise, your acquisition won't start. So put a random value. It doesn't matter if you are seeing higher depth. That doesn't matter. That's not your actual true depth. You have to calculate. You have to do the velocity sounding, and you have to find out the velocity values of the layers, and from there you can calculate the depth. Until unless you can't calculate the depth. Okay. So your seismic, sorry, data section will be offset, and your two-way travel time. Got it? So the next point you can see here, that is called rate. What is rate? Rate means scan per second. And you remember that I mentioned in the mode that mode could be time based. Okay. So if you are collecting data based on time, then this is very much important. So if your mode is time mode, this is very much important. Then you have to fix a value, you have to set up a value. Okay. So that suppose you are using a vehicle, you will be maintaining a constant speed, and you calculate the rate. Okay, you calculate the rate per second, how much scan it's taking. Okay. And if you are not maintaining that, then this will be beeping. So let me tell you a story. I was using time mode, and I have used one vehicle. I put my system, my chip 200 megahertz antenna behind a vehicle, and I was driving. Um, and what happened? It started beeping because I was going too fast. Okay, so I'll suggest do not go for the time mode system. Rather, you will be going for the distance mode system, and in the distance mode system, you have to select a specific value. Okay, so suppose this is a 100 kilohertz, you kept it's your T rate. Okay, and then your uh, rate could be 120 120 scan per second. It could be maximum 120 scan per second, but I'll suggest to keep it low. Okay, so if you are missing some point, if you are dropping a scan, then what will happen if you are going fast, or if you are going slow, then what will happen, it will start beeping. So I'll suggest you better keep it at 64 to 80. Okay, so I generally kept 64 in all the time. That's my that's basically compatible with my working speed and all the other settings. So rate will be 64. Okay, now what will be the scan per unit? The scan per unit is very much useful when you are doing a bistatic antenna point mode survey, or the point mode survey. In case of bistatic point mode survey, or in case of 200 megahertz antenna point mode survey, this scan per unit is very important. So suppose you have set up a unit where you will be setting up that unit. I'll be discussing this in the next video. That's in the system part, or that's under the system menu. I'll discuss that. So your unit suppose is meter. Okay. So scan per unit means how many scan you require per meter. Okay. Basically scan per meter, or scan per unit of horizontal distance. So this parameter of scan spacing, basically when you are using monostatic antenna and when you are using survey wheel, then you will be keeping the scan per unit around 40 or 50. So I generally kept 40. So 40 is okay. So having smaller scan spacing, if your scan per unit or the spacing means mean spacing is low or less, then scan per unit, scan per meter is should be higher. Got it? Okay. So suppose this is 1 meter, you was case doing this much of scan. Okay, now if you want to take more dense data, then you will be keeping this at higher values. Okay, and you have to consider the time it will take that time. So at your walking speed, I'll suggest 40 or 50 would be a good number for scan per meter. So what value you'll be keeping, 40 or 50. So this is for the beginning or for the inexperienced user. Later you can define depending on your condition, depending on your survey condition. Okay. Now another point you can see here under the scan menu, the last point, that is gain. Okay. This gain is for display purpose. This gain dB you will be giving to the entire signal for the display purpose. Okay. and this will not be saved with the data file, and does not have any significance. So just put a gain to see the signal you collected on the field. Okay. Next important point is called the gain. Okay, this part is very important. So you can use 5-point gain. When you select gain, uh, first you will be here you can see is selected auto. Okay, you will be selecting auto to, you will be first doing auto to manual. I'm telling you a trick how to set up the gain. Okay, so gain, why gain is required, let me tell you. When your signal is propagating downwards, it will be heavily attenuated. To counteract this effect, okay, or to minimize this effect, you will be using gain. And in GSSI system, you can use 5-point gain. Mostly all the GPS system you'll find they are using 5-point gain. And how you will be adding gain? So there will be values of GP1, GP2, GP3. By changing the point, what is GP1? What is GP1? What is GP2? So here it's showing GP3. It's a 3-point gain they are showing. Okay. So you will be seeing a oscilloscope, and there will be some gain point data like this. Okay, now this is gp1, this is gp2, this is gp3, and by changing this point, changing this value, you'll be seeing the signal. Now be very careful, because you are using gpr, you don't have much experience in gpr, and you have to be careful when you are assigning this gp1, gp2, gp3. If you give wrong gain to some point, okay, what will happen? Some extra feature will be, which is not actually a feature, will be appear, or would be appear on the radiogram. So you'll be seeing some extra features, or your actual features will not be um, recorded. Okay, so it will give you a totally wrong idea. So how to tackle this point? Now, how can you tackle this point? What is the trick? The trick is, first is might be in auto position, then you do it in a manual position. You select how many points you want to choose, like 3 or 5. Okay, so I'll go for, let's say, 3-point. Okay, 3, 4, or 5, 3-point or 4-point or 5-point. Okay, you chose that is a 3-point gain. Then you do auto to manual. In the manual, you will be choosing 3-point or 4-point or 5-point gain. Then again, you will be doing that in auto. Automatically, it will be adjusted. You don't have to think anything. No need to think anything. No need to think any other aspect. Okay. So when you do auto, then you do manual, you select the points, number of points, then you do auto, it will automatically do your work. So gain part is tackled like this. Later when you get experience, you can assign the gain, and or you can understand which number, what should be your GP1, what should be your GP2, what should be your GP3. But at the very beginning, you won't get an idea. Next point or next menu is position. So position, you can see auto, offset, or surface. So in the auto position, I'll suggest do that in manual. Okay, the position should be in manual, and you have to understand what do you mean by offset, what do you mean by surface, what do you mean by offset. So this is the offset means it's an internal system parameter that's basically describe the time lag. Okay, triggering the pulse inside of the control unit. And in this case, suppose you know that in monostatic antenna, theoretically, the transmitter and the receiver are on the same position. Theoretically. So at first, which wave will arrive from transmitter to receiver? Okay, and that will be the direct wave. So basically, this offset position will set up your direct wave. Okay, this will set up your direct wave. Second point is called surface. Surface will set up your ground surface. So it's a useful display option, and this will allows you visually to cut out the flat part above the surface, above the ground surface. So first you will be having a direct wave, high amplitude, then you will be having a surface wave, okay, and direct wave or air wave. So this is direct wave, this is surface wave. Now by changing the surface, you will be having a cursor like this. You will be having a cursor. So I'll be telling you, or I'll be suggesting you that put this cursor just above the direct wave so that you can have the actual data. So when suppose this is a common concept, or this is a common idea, that when you are generally taking a photograph of any scenery, you are taking some portion above, some portion below, so that you can get the context. Similarly, for the radiogram, you will be taking so suppose this is your direct wave, or is the maximum depth of signal penetration. This is your actual radiogram. But I'll suggest you to take, when you are collecting data, take some portion. Suppose this is the first break. Okay. So you'll be putting cursor here so that you can see where is the first break. Later you can do the time zero condition. So in offset, you generally do the time zero, or you'll consider the time zero condition. Okay. So you can do that, the time zero condition in the software. And I'll suggest you to take just above of this first break. Okay. So I think position part is clear. Next important point, that is the filters. What are the filters you should consider? So on this filter, I'll make another video. I'll make another video if I get some time. And what are the filters you should consider, that you should know? And this part is very important. This part is very complex, but I'll make this simplify for you, and I'll only tell you the some thumb rule. Okay. So the thumb rule is, which first you have to understand which filter you will be considering. You are seeing LPIIR, LPFIR. What is IIR? Infinite impulse response. Infinite impulse response is termed as IIR. What is FIR? Is finite impulse response. You got the idea. But which one you have to set? So I'll suggest you to set up the IIR filter, infinite impulse response filter. So one is low pass IIR, and that one is high pass IIR. So there is a thumb rule that low pass IIR should be less than 3 FC. What is FC? FC is the central frequency. In this case, it will be 2 megahertz. Sorry, 200 megahertz. Okay. What is HPIIR? High pass IIR. In this case, you have to select greater than equals to f by 4. So in general, I'll suggest, if you are setting this up, then this will be 600 megahertz as low pass IIR, and this should be 50 megahertz for 200 megahertz antenna. For 200 megahertz monostatic antenna. Got it? So that's the very important point you have to select. You will be leaving the FIR part. You will not be doing anything in the LPFIR or HPFIR. You will leave that part out. You will be only using this LPIIR and HPIIR. Okay, only these two part. Next is, you can see here the stacking. Stacking means at some point how many times you are sending a signal. What do you mean by stacking? So stacking is basically high frequency noise reduction technique. How we can use this? So this is basically horizontal. I'll not complicate this. IR filter. In lumen stuff, what is taking at some point, how many times you are at a single point or at any instant, how many times you are sending the pulses to the ground, and how many times you are recording that pulses. Okay, that is basically giving you the idea of stacking. You are stacking all the signals. Okay, now this stacking you can use either 32 or 64, depending. So if you are using 32, it will take less time to survey a particular area. If you are using 64, it will be taking much time. Okay, the idea, the concept is very easy, and I'll suggest to go for 64. Why? Because if you are walking and you are scanning, 64 is not that much big number, that much of big stacking number, and it's good, and it can complete your survey, or it will not be creating any problem if you are keeping it 64. So stacking should be 64. There wouldn't be any beeping sound from the system if you keep 64, and if you are walking and dragging the system, okay, at your walking speed it will be okay. Now this point, BGR removal, that is called background removal. What I'll suggest, do not use this system. Do not use this point. Whatever you do, take the raw data, do it in the Radar 7 software, processing software, or Mac GPR, whatever software you require. Do that there, but don't use during the connection. If you remove the background, so what you generally do, it generally removes in layman's term, or in a simple term, that you will remove some horizontal layering. So that could be some laminated layers it may remove. And in the field work, you might not be understanding what's happening. So I'll suggest, do not use the background removal technique. So it's a horizontal high pass. Uh, uh, it's a basically horizontal high pass system. So it's a horizontal high pass filter. So do not use the background removal. So that's it for today, and for my next video, stay tuned, and I'll be uploading my next video in the next weekend, if I get time. And next video will be on 80, how you can set up 80 megas antenna.